Section 7.2 is very similar to section 7.1. The only difference is that I have a multiplication symbol between two different fraction lines. So basically I'm doing the same idea. I'm trying to cancel things on top with things on bottom. The difference is I can choose either top and either bottom. Anything on bottom can cancel with anything on top. So for instance, in this A, I see a 6 on bottom, a 6 on top. Those can go away. I see 11 on bottom, 11 on top. Those can go away. Now I kind of like to do what I call counting X's and counting Y's. So on top, I count 2 X's here plus 3 more X's here for a total of 5. On bottom, I only count 1 X. 5 minus 1 leaves me with 4 X's on top. If I do the same for Y, there's 1 here and 5 here for a total of 6 Y's. On bottom, I have 1 here and 3 here for a total of 4Y. So Y to the 4th, Y to the 6th on top, 6 minus 4 leaves me with Y to the 2nd on top. All the numbers went away, so this is my final answer. Just X to the 4th over Y squared. Technically, it would be divided by 1, but then I would still report the answer as a final answer of X to the 4th over Y squared, because anything divided by 1 is itself. If I apply the same process to part B here, I can get rid of this 3 and this 3. This 9 and this 3 reduce. 9 divided by 3 leaves me with 3 on top. If I now look at the X's, I have 3 here and 2 here for a total of 5. Minus 1 on bottom leaves me with X to the 4th. I have 1 here and 2 here for a total of Y to the 3rd on top. Y to the 2nd on bottom. 3 minus 2 leaves me 1 on top. Again, this would technically be over 1, but I could write it as 3x to the 4th y. When I look at this problem, there's only one thing that's the same on top and bottom. This full factor, x minus 7, and this full factor, x minus 7. I could not, for instance, cancel this x with this x, or this 7 with this 7. The key here is that this is a whole term, x minus 7 being multiplied by 7. This is a whole term, x minus 7 being multiplied by x. As long as it's the whole term being multiplied, I can cancel a whole term with a whole term. But I cannot separate things that have a subtraction or an addition sign with them. Again, I could not cancel this x with that x. I could not cancel this 7 with that 7. That said, when these go away, I'm just left with a 7 on top. I'm just left with an x on bottom. If I wanted to rewrite D slightly, I could call this, instead of x plus 2 squared, x plus 2 times x plus 2. I then still have an x plus 2 on bottom of the first thing being multiplied. In the second thing being multiplied, I have an x plus 4 on top and an x plus 2 on bottom. This x plus 2 and this x plus 2 can go away. This x plus 2 and this x plus 2 can go away. So I'm just left with x plus 4 on top and an understood 1 on bottom. That's why my final answer would be x plus 4. In part E, I'm going to need to factor each part before I can figure out what can be reduced. So I'm going to factor this first part as 2 parentheses. Since it's just x squared, I'm going to put x and x. First sign is negative. Different from a negative sign is a positive sign. I'm looking for ways to multiply to 3 and subtract to 2. Well, the only way to multiply to 3 is 1 times 3, and 3 minus 1 does subtract to 2. So I'm going to put the larger number first, smaller number second. On bottom, I can't really do anything with that 3x. It just has to stay at 3x. I then put my multiplication symbol. 3x minus 15 has a common factor, specifically 3 that can be pulled out. If I divide 3x by 3, I'm just left with x. If I divide a negative 15 by 3, I'm left with negative 5. On bottom, I still have this x plus 1. When I look for what can be reduced, I have an x plus 1 on bottom, I have an x plus 1 on top. I also have a 3 here and a 3 here. Otherwise, I'd have to leave everything as is. On top, I would put x minus 3 times x minus 5. On bottom, I would just leave this x that remains. I believe you can put answers into the system like this. It's possible that when they show you the answer, they would have this multiplication done out on top, so they'd get x squared minus 8x plus 15. But I believe the system still accepts it if you just leave it like that in parentheses showing what would be multiplied. When we deal with division, we're going to end up doing pretty much the same exact thing as multiplication. We just need to do one change first. And that's specifically when you divide fractions, you flip the second fraction and it turns it into multiplication. So I rewrite the first fraction, 14x divided by 3. I change division to multiplication. What used to be on bottom comes to the top. What used to be on top goes to the bottom. I now see these 3's are a repeated factor that can be reduced, and these x's are a repeating factor that can be reduced. I'm left with 14 over 1, which just equals 14. In part B, if I do the same thing, I'm going to rewrite this as negative x squared over 10 times 6 over 2x. Here I can reduce this x and one of these x's to just make it x to the first. I can see that 6 and 2 have the common factor of 2, so I can reduce this and reduce this to make it a 3. I now have negative x to the first times 3 on top, which is negative 3x, and I have just 10 on bottom. So my final answer is negative 3x divided by 10. For part C, I'm going to do the same general idea. The only difference is I'm going to factor as I go. So instead of writing this as x squared minus 4, I'm going to write it as the difference of squares, x plus 2, x minus 2. On bottom, instead of writing 6x minus 12, I'm going to pull out the greatest common factor of 6. If I then divide 6x by 6, I just get x. If I divide negative 12 by 6, I get negative 2. Multiplication symbol, write what was on bottom, now on top. Write what was on top, now on bottom. If I cancel things that are the same, I can cancel this x minus 2 and this x minus 2, this x plus 2 and this x plus 2. That leaves me with a final answer on top of this remaining x minus 2, and on bottom, what remains is this 6. So this would be my final answer, x minus 2 over 6. Sorry that it runs a little into D. For D, I'm going to rewrite x squared minus 4 the same way I did before, x plus 2, x minus 2. On bottom, I can pull a 2 out of these. 2x divided by 2 leaves me with x. Negative 4 divided by 2 leaves me with negative 2. I can then write this as multiplication. In this circumstance, x plus 2 goes to the bottom again. X minus 2 goes to the top again. So I can still cancel these. I can still cancel these. And what I'm left with on top is x minus 2. On bottom is a 2. For part E, I'm going to start by factoring x squared minus 16 as a difference of squares. It's going to become x plus 4, x minus 4. On bottom, this x minus 4 stays as is. I'm then going to change the symbol to multiplication. What was on bottom, 2x, comes to the top. What was on top, 2x plus 8, goes to the bottom, but at the same time, I'm going to pull out that common factor of 2. 2x divided by 2 leaves me with x. 8 divided by 2 leaves me with 4. I can now see x plus 4's that can go away, x minus 4's that can go away, and 2's that can go away. Once everything's gone, all that's left is an x on top, which means my final answer is just x. For F, I'm going to factor x squared minus 10 as a difference of squares, x plus 10, x minus 10. On bottom, I can't do anything but leave it as x minus 10. I then change to a multiplication symbol. What was on bottom comes to the top. What was on top was 4x plus 40. I can take a common factor of 4 out of it. That leaves behind 4x divided by 4, which would just be x, plus 40 divided by 4, which would be a positive 10. I can then get rid of this x plus 10 and this x plus 10, this x minus 10 and this x minus 10. That leaves me on top with just an x and on bottom with a 4. When I rewrite G, x plus 7 over x, or 7x, remains unchanged. When I put the times symbol in, what was on bottom goes to top. What was on top goes to bottom. I I now have that repeated factor of x plus 7. I have an x here and an x here. Since everything went away on top, there's an understood 1 left over. So my final answer is that 1 that's left over divided by this 7 that was left over on bottom. For the final problem H, I start by factoring x squared minus 25. It becomes x plus 5, x minus 5. On bottom of that, I'm going to pull out a 2. When I divide 2x by 2, I just get x. When I divide 10 by 2, I get 5. I'm going to replace with a multiplication symbol. Used to be on bottom was an x plus 5. I'm going to write an x plus 5 now on top. Used to be on top was a 5 minus x. While I'm placing it on bottom, I'm also going to pull out a negative 1. So what used to be a positive 5 becomes a negative 5. What used to be a negative x becomes a positive x. I can now see that this x plus 5 and this x plus 5 can go away. This x minus 5 and this x minus 5 can go away. And what I'm left with is 1x plus 5 on top. On bottom, a negative 1 times a 2, which gives me negative 2.